way, and they may be able to decide what kind of motor to be used, number of pulses to be given for the motor in order to attain the motion, or what kind of feedback system can be used. All that can be understood once they understand how the motion is getting modified. So these are the three ways we would like to recommend virtual lab for an online classes as well as in-person classes. So with that, we have Beryl, can you give in the chat box the mapping? We have also mapped energy.
Yes, sir.
You already you're allowed to chat. Maybe we will.
Yes, sir. Chat is sir.
Yeah, we will provide you the link. We have done a rough map of your subject, that is NIT Warangal subject, to corresponding virtual lab. Please don't make it is an, what you say, a complete one, because our team has tried looking at the syllabus. We have just put it together. That's what we have done. Protect the other thing. Yeah. Other panelists kindly.
Yeah.
Yeah. So we have just put the link. You can download that sheet PDF, and that gives you our mapping. That is what we felt is a mapping, and the faculty who is taking the course will find much more number of labs available to map and show the demonstration. Now, what I will do is I will ask my other team members to quickly demonstrate 1 or 2 labs in different domains. Beryl?
Sure.
You like to have a question there?
No. Should I? So somebody is presenting. Right?
Yeah.
Yes, sir. I'll be presenting next.
Yeah. Fine. You are.
Okay. Yeah. Thank you.
Hope you are able to see the.
Sir, I think I just lost the presenter privilege again. Could you please assign to me back?
Yeah, they have removed the presenter privilege.
No. Please. Beryl?
Yeah, I've got it. Got it now.
Okay. So we want one subject at least from different domain to be shown to you, so that you can easily use it. That's what the idea is.
Sir, can I get a feedback? Is my screen is visible?
Your screen is.
Yeah. Thank you, sir. So, a very good afternoon to all the dignitaries, honored dignitaries, and respected faculty members from NIT Warangal. Myself, Beryl Thomas. I am a senior research fellow at Center for System Design, NIT Surat. So, Professor K.V. Gangadharan has already explained in detail what the philosophy of virtual labs is, what the concept is all about, and all such things. So, the platform we have over here, the virtual labs platform that I have already shared on the screen, it explains, it classifies the available resources. There are actually more than 120 labs created across 9 domains, 7 engineering as well as 2 sciences domains, which is as you can see over here. And there are more than 1,000 experiments on this platform right now. And there are a few other experiments outside this particular web page, which also I'll try to have a look into. So basically, we will not be able to touch upon all the experiments today. We will just show a few examples from different domains to make sure that people from different subject areas will be able to have have a basic idea of how this has been structured. So I'll be taking care of computer science engineering domain. So you can click the computer science and engineering broad area from this homepage vlab.co.in, which will take you to this particular page, which lists out a broad set of subjects from the computer science and engineering domain. So as you all might be thinking right now, computer science is a subject in which almost all the of practical subjects are after all virtual in nature. The faculty as well as students, they will be working on virtual tools like IDEs or compiler tools or development tools, different software on a computer itself for their practical experiments or practical subjects learning as such, except for the electronics oriented or circuit oriented subjects. So what exactly does what value addition does virtual labs do is what I'll just show in a quick way. So there are a large set of labs, and corresponding to each lab we can see that the name of the participating institute that has developed that particular lab. I'll take you to one of these labs, that is data structures lab. So here, as for the other labs that Gangadharan sir has already explained, we have the introduction, objective, the basic theoretical background about the subject. And once you go to the list of experiments, you will see the experiments listed out over here. From here, you can select one of the experiments. I'll go with the merge sort experiment now. So if you go to merge sort experiment, this as you can see, it's actually a newly developed lab. You can find over here itself, it is mentioned as a new lab. So there is actually an old data structures lab and a new one as well. In fact, two data structures new labs. So it's been an evolving process. The entire Virtual Labs initiative has been an evolving process where there were many labs that were developed in 2010, 12, 13, all those years that have presently become obsolete, and they are getting replaced by newer resources. So if you look at this particular lab of data structures, you'll find that there are a large number of theoretical resources. So data structures, it's a very conceptually deep subject. So for the student to get a good idea of the subject, a good grip over the subject, to use it in practical programming situations, they need to know the subject very clearly. They need to know the concept very clearly. So that's exactly what labs in computer science in general, not just for this one, in general, what labs or experiments in computer science on the Virtual Labs platform focus on, to give cognitive understanding, the best level of conceptual clarity to the students through various kinds of resources. So if you look at this particular lab experiment for merge sort, you find that there is a detailed introduction where you get an introductory video. So this new labs actually have a lot of video resources, additional video resources, using which the student can make a comprehensive understanding. Just beyond having a trying out things on a simulation, they can have a very clear conceptual understanding using the additional resources available. So you might also find such resources on other platforms like different channels on YouTube or on NPTEL. So there are, you will find that the focus will be slightly more towards the theoretical part of it. But here it will be more towards the practical implementation part of it. And here you find the self-evaluation techniques, pre-test. We have a pre-test before we go into the chapter. There is a lesson which covers the divide and conquer approach, which is implemented to make the merge sort experiment possible. The concept behind merge sort experiment is explained using a detailed video, and how sorting is a DNC problem is explained in a theoretical manner, and also there is a quiz for that particular chapter as well. Then after this chapter we go into the sort algorithm. The algorithm itself, again, it is explained with the help of videos as well as other images which give the students a clear understanding of what merge sort is before they can go into a demonstration of it. So in the demonstration, it is not directly linked to any programming language or any programming environment as such in this particular experiment. If you look at some other experiments, other labs, you'll find that some of the experiments will be demonstrated on in the backdrop of some particular programming language. You look at computer programming lab, you'll find that it is directly related to C language. But here in this case, it is not related to any programming language. It is just explaining the concept how the algorithm will work for a given set of numbers, for a given particular input. So in the demonstration, practice and exercise, we have 3 levels of demonstrations. So here, if you click next each time, what will happen is how the sorting process is implemented on this particular default array. So you can set up this array with the different sizes and different numbers. If you go into exercise, you'll find that you can give your custom arrays as well. So you can try the different cases, best case, worst case, etc. And you will be able to try out how the merge sort process works on an array of your choice. So that's how, if you click next each time, it will get executed one step at a time, and you will find that how exactly a particular swap or a no swap is implemented is seen on the observations. Here you get the message on what exactly is going on. And with each step by step, you are given a clear idea what is happening, how the sorting process is executed, and how the entire exercise is completed. So after the first subarray, it will go into the second subarray, and the same process will go through. So that is how it is implemented. So just to remind you, it is not linked to any particular programming language in this particular experiment. In other labs like computer programming and other labs, you will find that it is directly related to a programming language. There is Java related labs, and also there are labs where you have an online simulator also. So in this case, in the case of computer science experiments, you know that online or making the simulator itself, making the compiler or the code execution element online is not that relevant, because after all you have it offline. The students will have almost all the things offline also. So it's an additional resource, it's an additional supplementary resource the students will be able to use. And after the experiment part, after the simulation part in this experiment, there is a detailed analysis of the time and space complexity and all such analytical part of the algorithm, and also it has a comparison chapter with all the other sorting algorithms in terms of complexity, and also there is a quiz with regard to the analysis part itself, and also there is a post-test after the entire experiment, and there are further references and other such details as well. So this is how an experiment is normally structured on the VLab platform. So suppose you are looking for a particular subject or a particular experiment on this platform. You are navigated through all the labs on this page where your particular subject is listed, or you are looking for a lab in computer science. You are not able to find it here. Sometimes you might find it across in electronics. It might be a hardware oriented lab. You might be able to find it in electronics and communications. That's a possibility. Same way, electronics and communications, some subjects you might be able to find it under computer science. So speech signal processing or computer architecture and organization, VLSI, are all in-depth computer electronic subjects also. So sometimes you may have to look for your subject area that you are looking for in the related broad areas as well. And still, if you can't find a particular subject from the vlab.co.in/broad areas homepage, if you after navigating it, you can go to this page, this link called New Lab Development. So New Lab Development, it actually takes you to the VLabs development portal. So on the development portal, you can find the labs under this menu called Explore Labs. You can find the labs that are under development as well. There are 2 links, labs under development as well as approved labs. So labs under development are the ones that are currently in different stages of development, whereas approved labs are those that have been completed development and in different stages of evaluation before it can be uploaded or onboard listed out to the main page. So if you look at the list of labs in the approved labs page, you find that it is listed out together. It's not segregated according to the broad areas. It is listed together, and you can see labs from different domains that are under that have actually completed development and waiting for the evaluation to get completed. So you can look for the subject of your choice, the subject of your interest on this page as well. So I'll just show you one of the labs from this page also. I'll just go to database lab. It is developed by one of the nodal centers of IIT Bombay. So this is one part that that a virtualLabs nodal center or any other institute outside the participating institutes can contribute to this whole exercise. It's developed by Computer Science Department of Gujarat University. So this is some kind of a contribution that institutes, outside participating institutes in association with the participating institutes. So here IIT Bombay has supported this particular nodal center to be part of the development bandwagon. So if you go inside, you can see the list of 5 experiments, the different database statements is what is listed. If you go inside one of the experiments, you will still find the same format of theory, pretest is there, and also the procedure simulation. So here in the simulation, you have a execution window itself. So you can write your SQL queries over here. You have the instructions. You have to write the SQL queries over here and execute it. On the basis of execution, you will get a table structure, and the table structure can be saved onto your computer. So as sir has already mentioned, there is no logins or session saving online as such, because this system is attempted to be kept as open access as possible. So if you want to save a particular table structure that you have created at a point, you can download it from this credential option over here, and then it will save to your computer as a text file, and you can upload it back at a later point and continue working on a table structure that you have created once and may want to use it at a later point of time. So these were a few points that I wanted to add to this program. So with this, I will stop sharing my screen. So thank you, and I request Shrestha to take over to the next domain.